Some of the practice questions for areas of compound and complex shapes require you to calculate the area of a sector. So I'm just going to run through that briefly now. Essentially, what we begin with when we're calculating the area of a sector is we begin with the area of a circle, which, as you recall, is pi r squared. Now, if we look at that sector there and we imagine it subscribed onto a circle, the area of that circle, complete circle, would be pi r squared. It's actually easier to observe this in the second example at the bottom there, because we can see we've got the best part of the circle, and what we're losing in that case is a smaller sector or a smaller section of the circle. So we begin with the area of the circle, but what we acknowledge is that we don't have the complete circle. And in actual fact, what we know is a circle is made up of 360 degrees. If we have a sector of the circle where the angle is theta, then in essence what we have is we have a fraction of the circle, and that fraction would be theta, the angle that we've got, over 360, the total angle in a circle. So that there, theta over 360, is how much of the circle that we actually have. We could then multiply that by the area of the full circle, and that would give us the area of the sector. In the case of the example at the bottom, what we would do is we would calculate the area of the circle, pi r squared, but we would need to subtract the area of the sector. And the area of the sector again would be theta over 360 times the area of the circle. There is an alternative way to approach that one, which we'll come on to later in this video. So let's do some specific examples. If we take the radius of that circle as r, and we're going to use a value of r of 1.5 meters. And let's take the angle theta for that sector as 30 degrees. So theta equals 30 degrees. We can then calculate the area of that sector that's pictured, because we would do the 30 degrees divided by the 360. Now 30 divided by 360, if you do that on your calculators, gives you a 12th, or 0.083. That's how much of the circle we have. We have a 12th of the circle, or 0.083 as a decimal. We then multiply that by pi times the radius of 1.5 squared, and that comes out to be 0.589. The units of that will be meters squared, because we used meters as our radius. Now for the second one, I'm going to use the same values. I'm still going to use a radius of 1.5 meters, and I'm going to use a theta value of 30, just to emphasize the point here. So if we were to calculate the area, we would get pi times the 1.5 squared, because that's the area of the complete circle. But we need to minus the area of that sector theta. So we would minus the 30 again over 360 times pi times the 1.5 squared. Now that would give us the area of the larger sector. So we've got pi times the radius squared is the area of the complete circle, and that is 7.069 meters squared. But I need to minus the area of the sector. So I'm going to minus, open brackets, 30 over 360, close brackets, because that's how much of the circle's missing, times pi times 1.5 squared, 6.480 meters squared. And that's to 3 decimal places. Now there's an alternative way of calculating the area, and all we need to do is acknowledge this angle here. I'm going to call it phi. Now that angle there is the total angles in a circle of 360 minus theta. Now we know that theta is 30, so we've got 360 minus 30, which means that that angle phi is 330 degrees. Now we can use the same method as we used for the first sector to calculate the area of this sector. We know that we've got phi over 360's worth of that circle. So we've got 330 over 360 as a fraction of that circle, because we haven't got the complete circle. We're then going to times that by pi times the radius of 1.5 squared, and that should give us the same answer of 6.480. When we do 330 over 360 in our calculators, we get 11/12, or 0.916. So as a decimal, we've got 0.916 of that circle, times the pi times 1.5 squared, gives us the area of that sector as 6.480. So the method is different, but the answer is the same. Just remember that all of the other rules apply when calculating the areas of compound shapes. So you may have examples where you're adding a sector to a rectangle, or you're adding a sector to a triangle. You would calculate the areas of the individual shapes and then either add or subtract them accordingly.